had a great conference so far. And like the AV person said, I hope you had good breakfast in the morning. So with that, today we're going to talk about industrial OT security to protect your critical infrastructure OT devices. So my name is Trippe. I'm the principal technical marketing engineer from Palo Alto's OT and IoT security team. So in this particular session, we'll go over some of the threat landscapes within the OT environments and how we can secure the OT assets using Palo Alto's industrial OT security solution. And followed by case study on industrial OT security. So I'll take a real example of one of our customers and how we could enable them, starting from the problem statement all the way to the successful journey on the OT security.
Flip your mute switch, I'm sorry. For combining that to mute switch.
Sorry, we had some AV issues in the morning. So I hope you guys can hear loud and clear right now. So I'll start again, maybe for the folks who haven't seen this. So my name is Karthik Tumla. I'm the principal TME from Palo Alto's industrial OT security team. So in this particular session, we'll talk about the threat landscape within the OT environment and how we can secure the OT assets using Palo Alto's industrial OT security solution. And then we'll take a real world example of one of our customers. So we'll do a case study, how we started the journey of industrial OT security, starting from the visibility all the way to segmentation. So we'll take one case study and we'll go through that, and followed by some of the key design considerations you guys need to be aware of when you're deploying industrial OT security within your critical infrastructure environments, right? So this is a threat landscape within the OT networks, and like I said, like the threats are constantly evolving. Ransomware is on the rise. If you take some of the trends, what we have observed, one of the major trend is the unsanctioned internet connections from the OT network into the external world, like whether it is internet, whether it is cloud applications, and we have seen time and time, like the OT operators, for some kind of a patch download, they'll just go and enable this unsanctioned internet connections. And that actually leads to one or the other malware and ransomware attacks. And the other set of issues, what we have also observed within the OT environments is the ICS-specific cyber attacks, right? Because most of these OT assets are pretty legacy, right? They have prolonged uptime, they are pretty legacy. So we have seen like Cosmic Energy, ECANs, Stucknets. These are some of the ICS-specific malwares what have been observed within the OT networks. Because you are not going to patch this because you really care for the uptime. And the other issue what we also observed is the 5G and mobile LTE devices, because within the industrial world we have seen this robotic manufacturing equipment which is pretty much relying on this 5G networks, and now because of this we have seen denial of service attacks. So this is another trend what we have observed. And also the last one is the risk from the on-site vendors, where the vendors come in, they do one or the other thing, they plug in a USB, which can cause some kind of a malware attack or ransomware attack within the OT network directly, right? And also, oftentimes the malware gets propagated if you don't have a segmentation boundary like the IDMZ network. The malware gets propagated from the IT network into the OT network, right? If you have like a pretty flat network, that's what's going to happen. Like if you go and attack like in a Windows workstation, it will laterally propagate into your HMI, and from the HMI it will go and hit the PLC devices and the controllers, IO modules and all. So these are some of the trends what we have observed. So to secure any OT environment, you need three things. One, you need to secure the perimeter, which is your entire plant network. And two, you need to secure your remote network. Like if you have any reason for cloud connectivity, for remote operations, secure remote access, you need that to secure your cloud applications. And finally, you also need to have that consistent security service across the 5G and mobile LTE devices. Let's say if you have some kind of 4G or 5G devices, you need to have that consistent security services across the board. When I say security services, you need to be able to write the similar set of policies, what you're writing for the plant, you should be able to write the same policy even for the 5G devices. So with that, let's see how we can secure this industrial OT assets using Palo Alto's industrial OT security solution. So what we did was we took some of the pain points from the customers based on our discussion. I'm pretty sure you guys are aware, like we are pretty late in the game, but when we did it right? So we started with the asset discovery, but when we did the asset discovery, what we did differently is instead of leveraging the traditional signature-based approach, we went with machine learning and AI. And the advantage of this is we can scale to millions of OT assets, millions of IoT assets. There is no cap on the number of IoT devices or OT assets what you can discover, right? Like you can go and discover any asset type. And then once we discover the assets, since we are using ML, we can clearly define what is the baseline for these OT assets, right? What is a normal behavior versus any abnormal behavior? So we can go and we can discover that. Once we understand the baseline, if there is any deviation from its baseline, that's when we elevate the risk score of these OT assets. Let's say you have a HMI which is being manufactured by Rockwell. It uses SIP IP application. For some reason, it is going and using like a backnet application, which is being used by the building automation and control devices and smart building devices. That's a deviation from its normal behavior, right? Machine learning model will automatically go and detect that information, and it will elevate the risk score of that particular device. And along with that, we also have options to track the CVE information based on the vendor make and model, like using the National Vulnerability Database and a couple of other databases, we can go and we can track the CVE information. And on top of it, we can also visualize the assets across the Purdue levels, like all the way from level 0 to level 2, level 3, level 3.5 to level 5. We can go and we can discover these OT assets, and we can exactly plot them across the Purdue levels. And also on top of it, we can even discover the threats and vulnerabilities within the Purdue levels. So we can pinpoint, you can customize that as granular as you want. You can do it based on your site, based on your VLAN, based on your category of device, and you can create your Purdue visualization maps on the fly, right? So once you create that visualization maps, it helps in creating more effective segmentation policies, right? So that is where we went and create a more dynamic policies based on Palo Alto's device ID, user ID, and app ID technologies. So what I mean by that is, like, let's take device ID as an example. I can go and I can write a policy for my Rockwell HMI device saying that my Rockwell HMI can only talk to Rockwell PLC device. So that granular I could go by using the device ID as a policy construct, right? So that's the beauty of this technology. So we can leverage device ID, app ID, which is the application or the protocol. And also, if you want to do some kind of role-based access control, you can even tie user ID information into it. When I say user ID, you can take like a user role, like a Karthik can only access like a Siemens HMI through SSL application. Like I can go and I can create that role-based access control using the device ID, user ID, and app ID technologies. And then at the finally, if you look at it, at the end, we also have this continuous security inspections because we talked about ICS-specific attacks like malwares, like ransomware attacks, which are on the rise. So we can go and we can identify like Stuxnet, like Cosmos Energy, all these sophisticated threats and attacks using our threat prevention capabilities, sandboxing technology, and we can mitigate them near real time. So this is the 4 main pillars in securing their OT assets using Palo Alto's industrial OT security solution. So with that, how the architecture looks like, right? So this is a generic plant environment. And if you look at the plant environment, I have this level 0 to level 2, where you have your zones, conduits, which are typically used for segmentation. And then within that zones and conduits, you can see I have a line firewall where I can turn on the industrial OT security subscription. So the moment I turn on the industrial OT subscription on that line firewall, what would happen is we can provide the visibility of your OT assets, we can do threat prevention, and we can do contextual segmentation because the traffic traverses back and forth through the firewall, right? But in some cases, customers want to just start their journey at the IT, OT, DMZ level. So that provides more of like a demarcation between your IT network and your OT network. So we can provide that north-south segmentation. And along with that, we can also provide the visibility of all your OT assets. So how we provide the visibility of your OT assets is we can do span, we can do tap, we can do ER span, and we can provide the visibility of all your OT assets using some of these technologies. Right? We can do SNMP crawling, and we can identify the assets. So in terms of asset visibility, like I mentioned, one of our differentiator is using machine learning instead of static signatures or fingerprinting, right? So that way we can scale from the visibility standpoint. So what we did was the moment the device comes onto the network, we use our patented 3-tier machine learning model to classify the assets. So the first one is more of like a category view where we can identify that this is a generic HMI devices, and then within that we can provide the second level of classification saying that this HMI is being manufactured by Rockwell. This is the attributes like the firmware version, the serial number, the operating system. All that additional set of contextual data we provide part of that specific vendor make and model. And finally, we can also provide the unique personality of the device. That means if you have like a unique PLC from manufacturer from like Snyder or Rockwell, and if that particular device is talking to the internet, or if that particular device has some kind of suspicious port scan activity, we can go and we can detect that information using our unique context of the device. So that's our patented 3-tier machine learning model, where we start the device by the generic category, then we follow that with the vendor make and model, and then the third one is the unique context or the unique personality of the device. And then once we identify the assets, the next step is like visualizing across the network, how these devices are communicating with each other. So this Purdue level visualization map, which I'm highlighting here, you can clearly see how these OT assets are across the Purdue levels. You can go and you can plot them. If there is some kind of unwanted communication, you can absolutely go and block that. You can see the devices which are talking to the internet across the Purdue levels. You can see the devices which have access to some kind of rogue applications. We can go and we can detect any of that information from the Purdue visualization map, right? So once you have this level of data, it's easy for us to go and segment. So that's where we provision the contextual policies based on the device ID, user ID, and app ID. So device ID is primarily decoupling your device context across the IP address information, right? Like instead of writing policies based on like address 10.1.1.1, what I'm saying is this particular 10.1.1.1 IP address is a Rockwell PLC device. And then the app ID is more of like a comprehensive visibility of all your OT applications, like SIP IP, Modbus, DNP3, Red Lion, like these are all the applications, Siemens S7, like these are all the OT applications. We do have a broader protocol coverage where we can go and we can take this app ID to write the policy. And then the third one is the user ID, where we can take the user information from your Active Directory, Azure AD, and all that, and we can create more of like a hybrid role-based access control. So if you couple all that together, this is what it looks like. So in this example, I have a Siemens HMI device which is talking to the Siemens PLC and allowing access to only one application, which is S7 read. So you can see that granular we could go by writing the policies using device ID, user ID, and app ID technologies. So that way we can scale from the policy standpoint. And apart from that, the other capability, what we also possess from Palo Alto standpoint is we can go and we can automate the policy experience for network security administrators. I know NetSec really cares about simplifying the policy. So what we do is we take the behaviors of these OT assets and we can create the policies for you. And again, like when we say automate, we are not going to directly enforce a policy. From the Palo Alto network standpoint, we are going to recommend that to the firewall administrator. Now the firewall administrator, if he thinks that that's a relevant policy, all he needs to do is just import it and just enforce it. That's it. With one click of a button, you can go and you can enforce. So in this example, I have a Rockwell Automation PLC. It's using SIP IP read, SIP IP write. It is using NTP. It is using DNS base. It is using SNMP. These are the applications which are being used by the Rockwell PLC device. And now that you have this app level visibility, I can go and I can write a policy using like a few clicks of a button saying that create policy for my Rockwell Automation PLC devices, push it with one click of a button into my NG firewall, and the firewall will enforce a policy using that device ID, which is Rockwell Automation PLC. That means every time when you have a new Rockwell Automation PLC which comes into the network, it will go and hit this particular firewall rule, right? So policy will essentially follow the device, and we can massively scale from the policy standpoint. And like if at all you want to do this exercise manually, just think about it, right? First, you need to understand what that asset is, right? That is a Rockwell Automation PLC. Then you need to go back to the firewall and understand what are the applications the device needs to communicate with. And then you need to manually go and write policy individually, device by device basis. So it's kind of like completely cumbersome. And when we actually did some kind of a math based on our analysis, it's 20 times faster in terms of policy creation when you use this workflow versus like manually creating policies. So you can see it dramatically simplifies the policy creation time.
So how specific is that policy to the make model?
Yeah, so when we are creating policies, you can see that is a Rockwell Automation PLC, right? So we push all the attributes, what vendor it is, what make it is, what model it is. You can use any of this for policy creation within our firewall. And you can push any of these attributes into.
Okay. So you're not making the policy, you're giving the information needed by the administrator
Yeah.
to create the policy.
To create a policy. So we call it as policy recommendation, right? So because we don't know what business requirements you have, right? Like we recommend a policy and you can use that policy or you can discard it. It's completely up to the firewall admin. Yep, sorry, there was a question.
Essentially, your policies are static, right? You don't have a way to adapt the policy according to how your plan is evolving in your process.
That's a good question. I will say the answer is no, because if the traffic is traversing through the firewalls, we will automatically know what those behaviors are. So what applications that particular firewall or that particular OT device is communicating with. And based on that visibility, we can go and we can create more granular, or we can fine tune your policies. Because we already see the applications, what you're running in your environment, and the traffic is traversing through the firewall. So we can create that baseline information based on the info, what we gather from your network. So if we can monitor this for like 7 days, 10 days, or 2 weeks, we'll know, right, what's the baseline based on the information what we gather. And if there is any deviation from its baseline, because we know that a Rockwell PLC uses SIP IP, but if it is using some other application, that's a deviation, right? But we'll monitor it, we'll provide a baseline, and based on that baseline, you can go and you can fine tune your policies accordingly.
Your identity is basically the make and model of a particular.
Correct.
Right?
Yes.
So make and model is shared across whatever means, right?
Yes.
Serial number is the only thing that's probably going to be different.
Yep.
So how would you differentiate? I mean, the administrator is going to be utterly confused because he will have 1,000 Rockwell devices, right? And he will have to have really clear knowledge of, hey, yeah, this is the others for which of the 1,000 PLCs I have?
Yeah, that's a great question. So if you look at from the vendor make and model, you might have like a different model devices from Rockwell PLCs, like because we are talking not a generic Rockwell device, we are specifying a specific model of a Rockwell PLC, and we are using that for policy creation. And when you do that, you can also add additional attributes, like what operating system it is, what firmware it is, and based on that, you can write policies. But to your point, we are also enhancing these set of information to also include additional attributes where you can go and you can create based on like a serial number, other side of, so right now we don't have it based on serial number, but we are absolutely working towards that. So you should see that very soon. Next time, for sure, yep. We are enhancing that, right? So let's take an example of a device ID and see in a heterogeneous environment how we can leverage device ID to create the policies, right? So here you can see I have an ICS zone and I have a HMI devices which are in that particular ICS zone or a line level, right? So what I'm doing here is, there are some generic applications which are being used by the HMI devices like NTP, SNMP. We can create a policy for a generic HMI device saying that, hey, any HMI, I just want to allow access to these applications. And then if you have a device which is coming from Rockwell, I can go and create a policy saying that for my Rockwell HMI device, talking to the ICS zone, I only want to allow access to this SIP IP, which is SIP Ethernet IP application. Whereas for my Siemens HMI device, I can only allow access to like my Siemens S7 application. So that granular you could go and you can differentiate the policy. But you can have like a generic policy saying that for all my HMIs, I can allow access to like SNMP and NTP. So that's the beauty of this technology. You can create device ID in the heterogeneous OT environments, and you can create more granular policies and which can be fine-tuned according to your business requirements. And apart from that, we also have ability to detect using inline deep learning any sophisticated threats. We are talking about C2 attacks. Oftentimes, we are talking about like malwares, exploits, right? Oftentimes, control systems engineering workstation, which has access to the internet, gets attacked, and through that, the malware gets propagated into, like in the form of like a Trojan worm, gets propagated into the other set of OT applications, right? So we can go and we can detect that near real time using our inline deep learning capability. And also, we can go and we can identify the program download events. Let's say you are an OT operator and you are talking to a PLC device, and if someone issues like a PLC stop command, that can bring down the particular PLC. That will have like catastrophic impact on the plant, right? We can go and we can detect that OT level commands, and we can identify those program download events. So if someone goes and issues like a PLC stop, we can automatically generate a critical risky alert. We block that and we'll send a notification to the OT operator. So that's the beauty of this technology. We can read that program download events, and we do have that command level intelligence to protect the OT processes across the plant. And in terms of network design, there are two kinds of options you have. One is the IT OT DMZ firewall, which is the IDMZ firewall. So where you can turn on this industrial OT subscription, right? So you just use our firewall and you turn on the subscription, then we can provide the visibility of all your OT assets, and we can provide the segmentation north-south, right? This is one design option. And the second design option is you can place our OT firewall at the line level and you can turn on the subscription. So that means you can provide the visibility of all these line level, zone level OT assets, and on top of it, I can also do segmentation, which I showed earlier, as well as I can do native threat prevention, right? So that's the beauty of this. Like we can go deeper into the OT network, we can provide that visibility, we can do that contextual segmentation and enforcement with threat prevention capabilities, right? So this is a best case scenario. This is the recommendation what we provide. We do have a small form factor of NG firewalls you can place deeper into the OT network, like a PA460, and you can just turn on the industrial OT subscription and you can see the visibility. If at all you want to do this, like whatever I highlighted right now, right? If at all you want to do this exercise, you have to place a point sensor from some of our competitive products, and also you need to have like a firewall, which adds additional infrastructure cost and labor cost. And what we are saying is just use our NG firewall, turn on the subscription, see the visibility, see the enforcement. That way you can reduce the total cost of ownership and increase the return of investment. And also, I know like oftentimes you might ask like, hey, I don't want to send my traffic outside. Like what are the options do I have? If you are mainly caring about, or if you do have like a segmented OT network, what we have is this proxy option where we can turn on the industrial OT subscription at the line level, and we do have like a two firewalls which are sitting at the IDMZ level, which can get the information from the OT network, the metadata, which will in turn forward that to the cloud for processing. So this is mainly for the segmented OT network. So we do have this proxy solution which can provide that information. So this is mainly supported on Gen 4 platforms. You don't need to upgrade any of your OT firewalls, right? So this is only for the telemetry gateways which are sitting in the level 3.5 and level 4 and 5, right? For rest of your OT network, you can work as is. They don't have any internet access. They just sit on the they just sit in the OT network and just provide visibility. And in terms of the capabilities, you can see, according to the GigaOM radar report, they placed Palo Alto's industrial OT security as the leader in the market. So that shows the confidence on the analysts on our product. So one of the key things which they highlighted is we can provide the comprehensive visibility using AI and ML. That's one of our differentiation, which I highlighted earlier. And along with that, we also have more dynamic policies using device ID. That is also additional strength. And also we do have that intuitive UI, which you can play around, which is tailor-made for OT operators as well as critical infrastructure specialists, not just for NetSec. So where you can go and you can play around with this. And also we can integrate with your existing security stack. Let's say you have integration, we do have integrations with Rockwell Asset management, the factory talk. We have integrations with vulnerability scanners. We have integrations with NAC solutions, right? We can integrate with any of your asset class, any of your security stack, and we can provide that seamless set of policies across the board. So with that, I hope this session was helpful for you guys. And if you want to start your Zero Trust journey across your OT network, please reach out to us. We do have like a 60-day trial. If you are an existing Palo Alto customer, you can turn on the industrial OT subscription on your firewall, and you can see the visibility, segmentation, and threat prevention at scale. So thank you.